We want to do a sort of a series of the next 3 sessions and kind of connect them. And so we're going to make them pretty fluid. But the whole idea of the next couple of sessions is, you've heard how the standards come together, and we sit together and we hammer out, the core ideas, and we write them down, and we test them, and we interop them, and we plug fest them, and then the real world happens, right? So, so the focus of these next 3 panels is really what are the real world experiences that we have started to learn as we really started to build some early systems around these new and emerging IP-based standards. So, with no further ado, I'm going to introduce Thomas Edwards as our first speaker. And Thomas is going to share with us an overview of some of the current IP engineering work that's going on at Fox. And I have to say that Thomas conducted one of the very first demos I remember seeing of video over IP, and so he's really been a pioneer. And so Thomas Edwards from Fox.
Thank you. Good. I'm on? Okay, good. So I like to walk around and get back. Okay, so the good news is we went all IP at Fox. Everything's working just fine, so we can go. No, really. And I'll also mention Mike Wilkin, who's our partner from Fox Sports at the Network Center in Los Angeles, wanted to give this presentation, but we have the American League Championship Series, and he felt he really couldn't leave Los Angeles. So it's up to me, who normally, I'm normally kind of a SMPTE, VSF, AMLA, thinking about the future, doing testing person. Mike Wilkin is actually, organizing actual building and engineering of what we need in order to do our day-to-day sports activities. So this is what we were up to. So modern outside broadcast trucks have had a lot of challenges recently because their I/O capacity has just been increasing and increasing and increasing. You want 40 camera control units, 60 frame syncs, 25 replay servers, and of course some people in this audience have been making these huge switchers with 192 inputs and 96 outputs. Monitoring is growing, lots of multi-viewers across multiple trucks, lots of larger production monitors, 32-channel IPTV systems. And the question that's been faced by the people building these trucks is, how are we going to address this, given the fact we've got one coaxial cable per signal in the world of SDI, and that's heavy copper in a truck over time. So the motivation for moving IP in these trucks has really been a lot of the capacity issues. We've been starting in a world where 576 by 1152 was a standard one rack SDI router frame size, and that's just not big enough anymore. So if you grow beyond a single frame, it's linear for outputs, so you need 2 frames to double the outputs, and it cubes for inputs. You need 4 frames to double the inputs. So that was just not going to work out. You could not have 4 frames worth of SDI router. It was not going to be a success. The distribution diversity is also a driver here, because it would be nice to have your core router in one location and then actually have it only really break out. Oops. Did I do that? No, okay. Works all the time. In order to have it break out to the I/Os only where you really need it. And we're starting to get to a world of home run productions where we'd also like to have remote connectivity back to a central network center, and IP is a neat way of doing that. And of course, we're moving from HD to potentially 1080p 60, and then 4K and 8K, and who knows. So this is why we'd like to move to IP for trucks. So about a little over 2.5 years ago, almost 3 years ago, Fox Sports worked with Game Creek in order to create the Encore Truck series. So these are 3 53-foot double expando trucks. The first one, A, does audio and video. It's got some edit rooms as well as transmission. Encore B is where all the production and graphics are done. And Encore C is for replay servers as well as maintenance and storage. And it was all based around IP switching IP routing, I should say, of the video. A switcher, it's a Grass Valley Cayenne, so it's a 192 input by 96 output. The audio is CalRec surround sound console. It's based on the Evertz EXE IP video router, and it's running in an ultra-low latency mode. So it's 4 lines from encapsulation of the video to de-encapsulation of the video. Now, the audio router, the main audio router is not IP. It's a Evertz EMR. So this is something you're going to see in some of our implementations, is that the video is IP routed almost always. The audio is primarily still AES MADI routed, just given the situation of what was available when these trucks were built. Cameras are HTC 4300s, awesome cameras. Google there, and the EVS XTs for the replay servers. So this is what the IP distribution looks like in the Encore truck. In truck A is where it lives. You've got 28 RUs of the EXE as the core router. On the bottom, you've got CXP interfaces, which are very high-density IP interfaces. On the top, you have SFP pluses, which are just native 10 gig interfaces. So we bring in over 600 HDSDIs. They're encapsulated into about 228 10 gig Ethernets, and those are carried over 19 CXPs into the EXE router. We then have 420 10 gig Es, which come out to the multi-viewers. There are 35 different multi-viewers, and each multi-viewer itself has 26 HDSDI outputs. So lots of multi-viewing going on. We've got 3 10 gig Es that come out to 16 HDSDIs for the production display monitors. And then there are 120 10 gig Es that go to de-encapsulators for a whole bunch of random SDI destinations. For instance, the Cayenne switcher, IPTV, cameras, down conversion. And then to connect truck A to trucks B and C, there's 84 10 gig Es that come off, and that provides the capability of having 172 HDSDI outs and 104 HDSDIs in from truck A to trucks B and C. It's all controlled through the Evertz Magnum control system. It keeps track of all the devices, all the IP addresses. It keeps track of all the flows, all the destination IP addresses on the flows. So after they built the Encore trucks, they wanted to build something a little bit smaller, kind of aimed at baseball for the most part. So this is the Yogi trucks. So these are just two 53-foot expandos, again, based on the Grass Valley K-frame as a switcher, CalRec audio, and also the EXE IP router from Evertz. Again, Evertz EMR, a non-IP router for the audio, because again, it was felt the audio was not quite ready to go to IP when they built this truck. Again, HTC 4300 cameras and 12 by 12 channels of EVS XT replay. And if, by the way, if you're watching the World Series this year, it will be produced on the Yogi truck. So you'll see it in action. So back in the network center in Los Angeles, we also have a large Evertz EXE router. And the truth is, we basically ran out of SDI cross points on our existing Evertz EQX router. And it's like, what do we do now? So they made us an offer we couldn't refuse. We got the EXE router in. It now carries a little bit over 1,000 by 1,000 of HD signals inside our plant. So, we think in conservative, we're broadcasters, so let's just start doing monitoring only. And we're just about to put some, kind of air critical, maybe we'll call it internet critical paths. The OTT paths will be going on there in the near future. We've got, on the monitoring side, 626 HD videos come out to 84 IP-connected multi-viewer mosaics. So I think we've been kind of limited by the IP-native devices out there, and the multi-viewers were really the first IP-native connected devices that we could use in bulk. So that's what's the main use case. So currently, using about 650 out of the 2,000 or so 10 gig Es, which are capable of being on the EXE, about 20% utilization. It's in the neighborhood of 2.8 terabits receiving, 3.8 terabits per second transmitting. We're inside our network center. We're using in frame buffer mode, where there's one frame between encapsulation and decapsulation. And so the question is, what's our main takeaway? How has this really helped us besides just being an SDI replacement? And the one feedback I'm getting from the folks who put this in is that placing these gateways very close to the source and destination significantly reduces the cost, because if you've got this dense Ethernet coming in, you can just blow a couple of fibers from place to place inside of our plant instead of pulling a bunch of one signal per coax, copper coax. So this has been the one significant workflow advantage that we have based on the IP system. So I talked with some of our folks who do the troubleshooting and maintenance. And this is the exact quote: "The IP world is a true shock to those with SDI backgrounds." We're starting to do some CCNA training for the staff so that they can kind of begin to come up to speed. They first complaint, no patch panel to diagnose loss of signal, right? So that's going to be a hard habit to break. And sometimes they don't even know where to start diagnosing problems. So the question is if suddenly the signal goes away, is the SDI being encapsulated into IP? Has a gateway locked up? Is a redundant fiber had some type of problems? Is there just a dirty fiber? Or is there a bad SFP on a switch? And sometimes when you check the fiber to see if it's dirty, you actually make it more dirty, or you damage the fiber, right? So you don't want to do that. It'd be nice to try to do that in a hands-off fashion if possible, by taking a look at the SFP internal transmit and send data. The good news is the Magnum Control UI, which they're using, is exactly the same between the EQX, which was the Evertz SCI router, and the EXE, which is the Evertz IP router. So that helps. So that was probably the easiest part of this whole thing. So we're beginning a new greenfield project. We call it PCR 204 to try to bring IP out of the core and actually into production control room. So the concept here is use IP for signal distribution, have it be flexible for video depth that could be ranging from 10 to 16 bits if we want to have higher dynamic range. Integrate IP connectivity into production equipment as much as possible. So we try to avoid that encapsulation, decapsulation from SDI. We also want to align this with automated alignment of the stage resources and connectivity. So it's part of a greater automation effort. And also be able to dynamically allocate the required functionality in order to reduce operating costs. So try to do some analytics on some of the data we get out of that and improve our performance. Use knowledge management to improve the automation functions. To implement color grading for HDR and wide color gamut into our live workflows, and also try to identify and create properly associated metadata to go with those workflows. So that's the concept. And something the group designing this came up with is this concept of sustainability as a primary major goal. The capacity to endure. To have system monitoring with non-intrusive status monitoring of all of the equipment. Again, it makes it, you don't have to pull the fibers out to know if they're dirty, for instance. Analytics of all of those logs in order to try to optimize the system and equipment performance and reliability. Of course, this is something that people do today with computer servers all the time. They've got huge logs, they've got huge analytics, trying to make sure that you're doing a better job every time based on what you've done in the past. We'd like to put together some subject matter experts to develop the design and maintenance, operation, expertise using both formal methods, on-the-job training, and hands-on experience. Try to have formal and laboratory engineering and maintenance training to make sure that people know what they're doing. And then being able to update the systems and remove technology gaps and lower operating costs as technology changes and we move forward. So, our future strategy here with production control rooms have all the systems linked flexibly via IP with as few islands as possible, enhance our production automation, and to have redundant systems with automatic hitless failover, so that we, if there is some type of problem, it's backed up by a redundant system, and you don't even see anything on the screen. On the enhanced automation side, we think we can definitely automate stage selection based on scheduled productions. We think we can automate the routing of cameras, remote feeds, stage feeds like video walls and talent displays, as well as automation switcher mixer configuration. We're hoping to be able to automate multi-viewer configuration, tally configuration, and intercom configuration. And we're still working out DDR ports for the production control room, as well as graphics, and also doing various output feeds, like prompters and videos and cam ISOs. So, ultimately, this new suite will be the prototype for automating the control rooms. And hopefully, as we move forward, they'll be more automated, less resources to set up the show, using scheduling and resource management to automate the production business, and have that non-intrusive monitoring and full-time configuration and maintenance support, so that we will know exactly what's going on there, be able to solve problems, and be able to do the job better as we learn more about how the whole system works. So we also still move video over IP in our wide area network. And this is something I think it's becoming fairly mature. But I'll tell you a bit about some of the particular tweaks we've been doing the last year or so. We've got a private line network between Fox and Los Angeles, our main network center, between our location in the Woodlands, where we've been doing the interops, which is our primary sports network center, connected out to all of our regional sports networks locations. So we'll zoom in here. This is a movement of live H.264 video over IP. We've been using a combination of static SDN configurations on layer 2 switches for the setting up of QoS levels on layer 2, and also to do the proper flow steering. Every region has 2 VLANs. One goes to LA and one goes to the Woodlands. And we've got central video routing actually handled by Evert's IPX SDN switches. So it's kind of a combination of the IPX switches doing the routing and the Arista switches we have with static SDN configurations, setting up QoS, flow steering, the proper VLANs, and things along those lines. This is an example of direct flow, which is an SDN control on the Arista switch. So this is a decoder here whose destination IP address is 239.105.21.33. So we're saying if you have a flow, that you have a packet coming in, if it's coming in on one of those 4 Ethernet interfaces, 41, 42, 51, or 52, if it has that VLAN 2835 and it's IP and it's going to that decoder, it's send that packet back out of port 21, set its VLAN to 2335, and set its QoS class to class number 5. So the nice thing is we use standard router control panels in order to move these video flows across our private line network. Source, destination, take. The router control panels show all of the possible sources on our private line network, but they're only authorized for specific destinations for that site. So you can't, if you're in the Woodlands, you can't necessarily screw around Los Angeles. You're in Los Angeles, you can't screw around Woodlands, etc. We have diverse 100 gigabit per second wavelengths between our main sites, and as well as having a second carrier backup with diverse 10 gigabit wavelengths in case of emergency. And most of the regions are interfacing with ASI connections into IP media gateways. And we find this really reduces surprises, right? There's only so much damage you can do sending in an ASI signal into an encapsulator as opposed to just having an open network connection. So we've got about 128 flows coming into the Woodlands, 32 in Los Angeles, and 16 flows at the regions. And we're also rolling out a very similar solution to this, which will be going out to a bunch of venues which are utilized by the regional sports networks, both Major League Baseball, National Hockey League, and NBA venues with dual 1 gigabit per second connections. So for monitoring, we've been using a data miner to kind of flow up and accumulate monitoring information from a whole bunch of different devices. And it's very nice because you can split them out by site, and you can go in visually and take a look at a bunch of diverse devices within a single site and keep track of everything that's going on there. So in terms of conclusions, I'll say IP is clearly a no-brainer for the live video WAN. So the wide area network, it's no-brainer. Everybody should be doing it. Everybody probably is beginning to do it at this point. We're finding now that having wavelengths and SDN are really giving us very precise control of our flows, and we really like that better than MPLS-based solutions. IP is great for large truck routing, and I'll admit that still there are trucks which are being built which are not quite big enough where the advantages outweigh the costs and the difficulties. So there still are SDI trucks being built, but they tend to be the smaller trucks. The big trucks now tend to be all IP built. There are not a lot of IP native endpoint devices yet, but this is improving. I know some people in the room have IP connected cameras now, and it'll be coming along. Our network center implementation is really growing organically on kind of an as-needed basis, because sometimes if it ain't broke, don't fix it. IP monitoring is a complete no-brainer. It works really great, and it works super well with IP input multi-viewers. And we're trying to use new greenfield opportunities, like building a new production control room, to try to expand IP utilization within our plan. So that's what we're up to. Thanks so much.
Thanks, Thomas. Thanks for sharing those insights. We'll have time for discussion and questions for Thomas when we break for the panel, but let me introduce our second speaker, who is Tim Canary. And Tim is Vice President of Engineering at NBC Sports, and he and his team are responsible for lots of that great magic that we're so proud of here at NBCUniversal. Tim?
So, thank you. It's great to be here. My goal is to give you an idea, as much as I can, of what we did, what we installed, how we arrived at our decision, some of our design considerations, the client needs, how we're running today, some of our future thoughts towards 2110, and also some lessons learned throughout our project. So, back in 2014, prior to the Rio Games, our baseband router, much like Thomas described at Fox, was full. So we didn't have enough I/O to support what we needed to do for the Rio Games. So started looking at expansion, and we actually had design and expansion to go to 2304 fairly easily. But as we looked, we said, is that the right thing to do? Is that going to make sense long term? And we kind of thought no. So we looked at the legacy routing technology. And as we looked out, the first plan was to add 2 more EQX frames to get to 2304 outputs. That would have solved our needs for the Rio Games, and this is back in the Stanford facility quite nicely. Then as we expanded more, we said, well, getting beyond that might not be the best thing to do. So when we started looking at IP, we said, we'll keep what we have. We'll expand with an IP router, encapsulating the feeds that we have, and then we can grow upon that. We populated short to start. We would populate more fully and have a more extensible system that could service down the road. And what we find, as I think everyone's finding, is that IP infrastructure is going to be the only way we're going to be able to keep up with the routing needs, not only in trucks but in facilities as well, because the needs from clients just keeps growing and demanding. So our core routing expansion, as we explored the benefits, we knew we could leverage the existing control system, which was critical for the end user. They didn't want to be using a different panel, a different type of panel. It had to be the same. We could leverage the existing expansion plans and easily encapsulate all of our feeds with what Evertz calls the IPG 570. And there's one piece that let us, the capability to do it very quickly, which was our whole facility is based on X-Link connections in and out of the router, or on the input side, I should say. So a coax cable that hits the jack field goes to an X-Link splitter, and that goes into the baseband router. There were outputs available on that X-Link split that we could quickly bring into the IP encapsulation device, the IPG 570, and quickly encapsulate all 1152 feeds very, very rapidly. So X-Link, it's nothing magical. It's a passive splitter. and it was originally installed, so that made it very, very simple for us to move forward very rapidly with IP. So you'll see here, this is the back of the IP gateway cards. Each card has 18 inputs. We were all designed at the outset for 1.5 gig. So to go 3 gig, we're going to have to expand on more bandwidth, more ports. But each of these has 18 sources going into it. On the front side, we originally only had one EXE router, and our diversity plan at the time was going to be kind of top and bottom of the frame. We were going to have things split between them. And also our plan was also monitoring only. We were going to step very cautiously and just use this for monitoring. But that changed very, very rapidly when more projects came down the road, so monitoring only was not in the cards anymore. So I'll get back to that in a little bit when we talk about how we implement it into our test control room. But like I said, everything is 1080i, 1.5 gig uncompressed. We originally thought we would go 2022-6. That seemed like a safe, logical way to go. That changed as well. We encapsulate, de-encapsulate in and out of the router, so we don't have any native IP devices except for multi-viewers, and we just got a tech scope that we have now. We're shortly hooking that up as well. But we really wanted to keep it simple, and again, the initial plan was monitoring only, and we were not going to use it for higher risk production activities out of the gate. This is the original EXE frame on the left. All of our fiber I/O uses MTP connections. We started at one point with LCs, and we quickly saw that that wasn't going to work for us. There's just way too many cables and too small of a spot to go with LCs. MTPs work very well. But we also knew that planning was going to be key to success of this. So our original fiber infrastructure, as you see in these 3 racks, had about 192 duplex fibers across these 3 racks for the bulk of the facility. Was never going to make it for IP needs. So we embarked upon what we had called our fiber highway in Stamford, and we put some new fiber infrastructure in place. And this is a room with 4 racks of telect equipment. We looked at a few manufacturers. We liked these because of the way they handled the fiber. And so now we have 9,216 duplex fibers capacity versus about 576 in 3 racks. So this part is really key to get right as people are looking at facilities. You can't underestimate the need for fiber infrastructure done well. So what happened was we had this plan for monitoring, and all of a sudden we had to build a new control room. And there was no way we could keep the baseband router for all of the production needs and the IP router for monitoring only. So we built what we call PCR8. It's interesting to see the parallels between how we've done things. The big difference, though, in this is that Sony switcher is all baseband I/O. So we, much like on the Game Creek trucks, we de-encapsulate back to baseband ahead of the switcher, and then we encapsulate back where needed back into the router. I will say that all the outputs of this room actually hit the baseband router, and that in turn gets copied to the IP router. We don't yet have any inputs that are only on the IP router at this point. That'll be coming down the road. So some of our things that we had to do is a hybrid baseband IP, a much smaller room design. This is only 2 decks, far fewer seats than our large control rooms. We moved away quickly from 2022-6, and it all revolved around independent essence capability, getting to audio video separately. And at the time, keep in mind this was in the 14-15 time frame. The only way to do that, something that was shipping and selling, was using Evertz's Aspen protocol. So it's all based on Aspen. We quickly went away from the 2022-6 to Aspen. And I will say production needs can push us way beyond the comfort zone for IP, which I think that was good for us. In the end, we learned a lot. So we evaluated the 2022 plan. We escalated our hardware redundancy plans. We bought a second EXE router. So instead of having a top bottom of the frame, we have a whole separate frame in a separate room with separate power and cooling. But we had to deal with timing and also backup plans. So in that room, we do have some sources that go directly to the switcher. We have a handful of things so that if, God forbid, that router went down, we still have a way to get something on the air. So initially, we were looking at demuxing all the audio using standard demuxes, either Calrec demux hardware or Evertz, Grass Valley, or others, to demux ahead of the Calrec mixer. And that would have worked fine. There's no question we could have done that. What we decided to do is with the Aspen protocol, it allows us to take the transport stream out into a frame that brings everything out to MADI. And the key here was that for the end user, that audio operator, when he routes a signal, he doesn't really care if it's Aspen, MADI, baseband, whatever. He just knows when he hits that button, he needs that signal there at his mixer. This has worked well. It's actually worked quite well for us. We use it every day in this room at this point. At some point down the road, we will be going to a full IP input switcher at some point. But for now, our needs are met based on what we're doing at this point. And I'll say the multi-viewer is all a VIP 10G product from Evertz that's fed right off the IP router. So timing was a challenge. Not a huge challenge, but a little bit. So I won't go into every detail, but if you look on your far left, our reference point of these sources, we had some things that went directly to the switcher and other sources that went through the IP router. We wanted those to all be in time. So we needed that to be at a point where between the two, whether you took a source direct or through the router, much like the olden days of baseband NTSC, where you're trimming back cables to make everything match, or with delay DAs, we ended up putting in a line delay in some of the sources to line them up. And that has worked fine as well. That once we figured out the timing windows and looked at that across the board, that has worked quite well for us to deal with the timing variances between those sources going direct or through the EXE router. But patching was easy in the IP world. It was intuitive and visual, and like Thomas said, like this is to the operators and engineers, this is kind of like the scariest part, because to solve a problem, you're no longer looking at a patch cord, you're looking at that. And how do you do it? You can't just indiscriminately pull fibers off, and you can't walk up with a equivalent of a handheld TSG 95, stick it in and look at a picture. Those don't really exist anymore like they did. So what you're using are things like this. This shows both of our EXE routers. In the center on the left are all of the IP gateways encapsulating the sources in, and on the right are all the IP gateways on the output side. Just looking a little bit closer, that's just one gateway card saying, okay, from that gateway card, it's feeding both routers, and that's working, and then you can look at a list of sources on the right-hand side. So these tools become critical, and it doesn't matter what manufacturer, we just happen to be using Evertz, others have similar tools. But being able to inspect those pieces and see where your signals are going, what the signals are, I can't emphasize enough, it's not a patch cord anymore, and that makes it very difficult for some people to accept. One of the things I just want to point out is oversubscription. All the scribble on there, that's talent just testing the telestrator, so excuse the penmanship there. But I can't say it's been a perfectly smooth road. Everything works and works well. One of the things that we have seen is oversubscription, where in a VIP 10G, some of the links were oversubscribed, and that's what it looks like. So you get the call from the control room, you go running down there, and something's not right. We've since fixed that. That was in a control system change that we did where it was not dropping the prior source on that link. And once we fixed that, everything was fine, but it's responding to those things that it's like, what do we do now? How do we fix that? What's the challenge? It's just different than it used to be. So future, migration, vendor collaboration is going to be key for sure. That's a big part of what we have to do. Our original target was Aspen. We kind of thought that that was a transitory plan, and we still think that. I'm sure that we will be at 2110 at some point with standardization, but we're not in any hurry to do that. Everything works fine. We just don't need to do that right now. But I think down the road with switchers and other off-the-shelf hardware being 2110 capable, we will need to do that for sure. So we'll likely remain baseband well into 2018. Some of the lessons learned, vendor collaboration was really, really important, not just between vendors, but for the primary vendor, and it continues to be very important today for service and support. Planning paid off. It was definitely a challenge to make sure that all the planning, especially the fiber infrastructure, was what it needed to be, not just for that project, but for the future. You'll see I have client expectations were met, and that's a success, but it's also a challenge. Although the client expectations are met, when there's a problem, we're not able to as quickly diagnose things as we used to be. And that has definitely been a challenge across the board. The hitless merge feature between frames, that works very well. We experienced that during the Olympics, back in Stanford. That worked well when we lost a line card during the games. But also the big lesson learned is not being afraid to modify our plans, going from 2022-6 to Aspen, adding redundancies, and changing our fiber infrastructure down the road. Some of the lessons learned, and we can certainly answer questions about this as well. Support staff training is critical. This will take time, and as people get more familiar with it and are more used to looking at different systems than they used to, in a different manner than they used to be, that's actually getting better over time, but we still have those people that look at this and they're challenged because it's wildly different than what it had been. Solid PTP system is critical. We learned that the hard way. It didn't fail on air, but it was close to it. But when I say a solid PTP system, not just knowing you have PTP, but looking at all the failure modes across the board: sync generator failure, switch failure, redundancy across the board, and testing all that stuff. It's hard to admit mistakes, but that was one mistake that we made in our implementation. And I can't emphasize enough how thorough system testing, across the board. We probably would have seen that a little bit sooner had we pushed harder for some testing. COTS is a lesson learned. I'm a firm believer that commercial off the shelf has its place, but I think until we see that major interoperability between all vendors, I think COTS down the road is going to become what we would like it to be. But today, I think that there's still a lot of commercial off-the-shelf product from different manufacturers that will work well together. I've seen a lot of implementations where things may not interface well, even though that they are COTS. I think certainly that's going to be key to making it work better down the road, that we have more interoperability between different vendors. We talked about fiber optic cleaning. It's very similar. You can't just pull them off in thorough system testing. So that's it.
Great, thank you, Tim, very much. And again, a thanks to Thomas. Thank you both for sharing those insights and lessons learned.
So, and I'll assure you, we did not synchronize our presentations ahead of time.
That was really interesting.
It was scarily similar, yeah. So great minds think alike, right? Yeah.
Right. We only have a little bit of time for questions, so I'm going to actually ask Thomas and Tim if we'll do a couple questions now. If you guys would also come up and rejoin us at the end of panel 4, that'll give us some more Q&A opportunity if you'd be kind enough to do that. Let me ask the question about failure modes. Tim, you kind of showed what happens when a link gets oversubscribed. What other failure modes have you both seen that are just different than we experience in today's SDI world?
I think there's a lot of the video suddenly goes black, and you're like, why did the video suddenly go black? And I don't think that's any unusual. We see that in SDI as well. I will say though, we've had a long period of time now where everything's been really, really solid, and that's why we're starting to put some non-monitoring paths on the EXE router. It's working fairly well now.
And similarly, video is black, oversubscription. Once we figured out the keys to that currently is not an issue. But we have had hardware failures, whether it's gateway card failures on the encapsulation side or line card failures. And it's not a common thing, but it does happen. And that's where the redundancy of the second system and the hitless merge paid off.
Great, thank you both. Tim, you showed us a pretty scary debug instead of a patch panel with that software screen. If both of you could invent what kind of test and monitoring capabilities were to exist in a future software world, what would they be? What would it look like? What kind of walk through the system and show me different points can you envision as we look forward?
You're going to have some sort of monitoring tools that are all tied together. And again, it's not meant to be an ad for Evertz, but they're developing these tools all the time. They have a thing called Insight. We combine that with View and other products as well. But I would love to have, I'm sure many remember the TSG95, the analog scope from Tech. You plug something in, you see it. Something that simple would be great. And I think we have to get to that point that we can inspect things very, very rapidly.
Yeah, I think Fabrics and there's another company, ProVidea, also have handheld 2022-6 Aspen 2110 devices. So it's coming, but.
What's the biggest advantage? I mean, you both talked about advantages, but if you could pick one thing, what's the biggest single thing driving us towards IP, and what's the biggest thing to be afraid of?
Well, I mean, I think what drove our engineering people to IP was just a capacity issue at the end of the day. And it sounded like you had some similar situations. The density just could not be beat, and that's really what kind of drove us forward. But I think we'd like to begin moving to the more dematerialized world. We'd like to get software-based functions running in virtual solutions, but they're not quite there yet.
Similar capacity was certainly something that drove it, and I think looking down the road, we're looking at the ability to move large amounts of signal over dark fiber, and we'll be doing that early next year, and we can quickly take a 10 gig interface, plug it in at each end, and have 18 signals pop out the other end, and very, very simply and cost effectively as compared to years past.
I'm going to pull a question from we talked about for later panel. Thinking ahead in terms of migrating formats, we've had these kind of issues and growing pains, I'll call them. Just getting one format working in a plant. How do you think about the multi-format plant where we might have traditional HD and 4K and HDR or different combinations of HDR? Was we really talked about a multi-format plant? How does that change your thinking about system design and monitoring?
Well, on the system design side, like I said, we're all 1.5 gig bandwidth designed in and out of our gateways. So we have to double that bandwidth. So it's double the amount of ports in there. Managing those different formats, I think we can do that within the control system. But certainly, as we go forward with 1080p HDR 3G, which is one potential outcome, we're going to have to look at our bandwidth needs for that and grow those over time.
And our new production control room project has explicitly a 4K requirement. We are beginning to do a couple of 4K events with, we've done it in the past with DirecTV. We're going to start doing some college football with Dish. So this is something that we need to have some capacity to look at inside our network center, not just go from the venue to the to the satellite carrier. We need to go through our network center. We need to take a look at it, be able to insert the kind of graphics we can in Los Angeles.
Great. Let's take a couple from the audience.
Yeah, there was a bullet point up there in regards to the criticality of PTP infrastructure. I was wondering what tools are available for testing/monitoring PTP.
Well, in our case, there are tools within the control system that you can look at it at different points and make sure that, say, the router is getting, actually it's PCR by the time it gets to the router, but if it's not there, then you just work back upstream to the generators and diagnose where the challenge is. There's no simple way to do it other than looking at the tools, in our case the 5601 generators, looking at those, looking at the Grandmaster proxies and making sure that everything is set appropriately. I think the monitoring tools are going to get better for that as time goes on.
Yeah.
Well, clearly you've got to know that the PTP is making it to all of your endpoints as well. So that's another challenge. It's not just a one-point issue. It's your entire plant. So those endpoints really need to report back.
So I would think in a PTP situation that you could have more of a transient issue where went out of sync because a switch became oversubscribed and then goes back to working correctly. Is there any means of finding that and measuring that? I could imagine that would drive you crazy if that's happening a couple of times a day and then going back to normal.
Oh, it does. I can speak firsthand of that. You know, it can drive you nuts. You know, we had pops and clicks in audio, and it was directly as a result of PTP being out of sync. You know, and once we realized that, it was an easy fix. But finding that, you know, we knew there was a clock reference issue. We just weren't sure what the cause was or at what point in the path was causing it.
You should be able to set PTP at a QoS level that's above everything else. So even if you do accidentally oversubscribe the video, the PTP should be able to flow through. And again, that's on COTS switches. You know, obviously we're not implementing COTS switches in our plants yet, but that's something that you have the capability of doing.
We touched on security quite a few times. Are you doing anything specific in terms of security in your build? Besides a walled garden approach, or?
Yeah, at this point, it's pretty much isolating the video networks from everything else. I think it's just, you know, given the current maturity of what we're doing, that's probably the best thing that we can do. I don't see a converged, you know, media / file / email / web server network for a while. I'm sure we'll get there. And this is what happened with voice over IP, right? Voice over IP started as, well, this is the voice over IP network. And then as bandwidth increased and security got better and people got more comfortable with it, you could start mixing things.
Yeah, and similar, we're isolated, but then you have the Windows-based control systems, and that's a constant pace of patching, antivirus scanning, and those things at this point.
Great. Oh.
A quick question. Do you see, have you noticed a lot of your field engineering shift back to a NOC rather than being in the field with your remote productions? In other words, how many, you know, with IP, all this IP, you can analyze that back someplace else. You don't need to be on site. Or,
I was definitely, there's, and not for us yet with IP routing, but based on some of the economies of scale of things, we're doing much more, many more productions back at home than we had in the past, and that's just going to grow. You know, and there is a lot of back and forth between site, where site is much smaller, and the stuff back at home is much larger than it used to be.
Yeah, our VenueNet fly packs actually have a little cellular modem on them. So, you know, we're, even if all else fails, we have mechanisms to remotely control the encoders on those fly packs. So I think, yeah, we are seeing a situation where the connectivity out to regional networks, out to venues, becomes more easy to control from a central site.
Okay, we've got two more questions, one in back and then Howard, please.
Hey guys, I run a team of about 30 support people, all of whom I would describe as traditional broadcast engineering. Everybody talks about the pain points being training these guys up. Did you find it was more useful to, or could you talk a little bit about how you did that, or did you take from other teams and integrate, or did you do new hires, or?
We did a combination of some new hires, but also taking people that were, you know, the emergent leaders in this area and brought them to training, in this case to Evertz, where we need to. Also, Cisco training, ICND and other things are very helpful as well. Some of those parameters and concepts are common across the board, but at some point there is some specific vendor training that has to happen. I'm a big proponent of sending them to the vendor, be it Grass Valley, Evertz, or whoever, because I think that it's very difficult to do that with all the tools and things in one's plant.
Now, I hope in a perfect world, you don't have to train a lot of the hands-on people that much in the precise details of IP and Ethernet technology. Hopefully, the vendors should be able to provide solutions which, you know, don't require that level of transparency. Everything should just work. But I think especially in this initial time period we have right now, it is good that you have people with CCNA training and things along those lines, because the abstraction layer is not quite there yet. The perfect abstraction layer where we don't have to worry about the packets moving on the network, we're not at that point yet.
Yeah, a question on your networks. Are you doing physical separation for your networks, say PTP versus your data essence and that stuff? Are you doing VLANs, or is it starting to merge together?
We're separate. Our PTP network is completely isolated from everything else. If we need PTP for another purpose, we'll get it in another manner versus from the broadcast PTP devices. Does that answer your question?
Okay, last question.
Okay, very briefly. I think you, if you're currently running Ebert systems and whatever, that has a particular architecture that's kind of assumed based on the choice that you made. But as you move more into a 2110 world, do you view that you're going to have to build networking system architecture knowledge within your own organizations? Do you view that you would outsource that to an integrator? Have you thought about that yet?
For us, it would be a combination. I think it's leveraging the vendor's knowledge in those cases. From the 50,000-foot view, the router itself doesn't care what the signal is. It's just IP. As I'm not telling you anything you don't know, but all we have to do in a sense is change the encapsulation and decapsulation method, and we'll be in a 2110 world. But it's all the other stuff that goes with that, control systems and such, as well as perhaps going across a wide area network through other routing.
So I'll say our existing broadcast data networking folks are really excellent, because already last 5 or 10 years they've been moving to file-based workflows. They've got to move gigabytes and terabytes of data across the network in a secure fashion. So they're up to date with best of breed security solutions and network infrastructure engineering. However, now we need to take those folks who are over here moving files, and these folks who've been moving SDI, now they're moving live IP flows, and we kind of need to bring them all together. So that's I think the big organizational challenge is having the handoff of moving the video flows to people who have that high level of expertise in network engineering.
All right, I'm watching our time, so I'm going to end this session, but join me in thanking Thomas and Tim, and they will certainly be around later for more questions.